The diagram shows the graph of y equals fx, where fx equals x squared minus 2 over x minus 2, where x does not equal 0. A. Use the graph to find 1, f of 1. So in order to use the graph, this graph shows the function f on the y-axis, and the x-axis is the input of the function. So we want to find f of 1. That means we need to go to 1 on the x-axis, draw a vertical line, and it hits the graph right here, which corresponds to a y-axis value of minus 3. Therefore, f of 1 is equal to minus 3. And we can actually just calculate this from the function. So you can actually use this to check your answer. So if you substitute 1 into the function, you should get minus 3. Okay, and indeed we do, so the answer is correct. 2. F of minus 2. So that is the same as putting the output value of f of minus 2 into the function again. So first we can work out f of minus 2. If we use the graph for this, we can go to minus 2 on the x-axis, draw a vertical line, and it corresponds to a y-axis value of 3. So since f of minus 2 is equal to 3, f of minus 2 is the same as f of 3. So again, using the graph, we would go to 3 on the x-axis, draw a vertical line, it hits the graph here, corresponding to a y-axis value of approximately 6.4. So the answer is 6.4. So again, we can also use the function to check your answer for this. You can just substitute minus 2 into the function, get 3, and then substitute it again to get around 6.4. B. On the grid opposite, draw a suitable straight line to solve the equation x squared minus 2x minus 7 equals minus 3. So what we have here is, we already have the graph of the function that is drawn on the diagram. So in order to draw just one more suitable straight line, we need to rearrange that equation so that one side of the equation is the function that we already drew. So if we need to rearrange one side to be x squared minus 2x minus 2, first we need to change the minus 7 into a minus 2. So we can plus 5 to both sides. And that changes the left-hand side to x squared minus 2 over x minus 2. And the other side is minus 3x plus 5. Therefore, that is the other line that you need to draw. So you need to draw the line y equals minus 3x plus 5. And if we do that, it's a line with a y-intercept of 5 and a gradient of minus 3. So the line should look like this. And to solve the equation, you can use a graph if you draw the graphs of both sides and find the point of intersection. So if we use the graph, we're just trying to find the points of intersection between this curve and this line. So the points of intersection are over here. And the x values corresponding to that are minus 0.3, and the other one is around 1.7. C. By drawing a suitable tangent, find an estimate of the gradient of the curve at x equals minus 2. X equals minus 2 for the curve is over here, corresponding to the x-axis at minus 2. So what you want to do here is use a ruler and then use it to aim at that coordinate so that it goes in the same direction as your graph at that point. This might vary from person to person, that's why they say estimate the gradient. And draw a straight line that you think looks like a tangent. Then after that, you find the gradient of the straight line by using gradient equals change in y over change in x. So to find change in y over change in x, we need to draw a right angle triangle down here. The change in y goes all the way from 6 to 0. So the change in y is like -6 because it's going down. And the change in x is over here. So the change in x goes from -3 to around almost 1. So that's 1.8 roughly. Therefore, the gradient is equal to change in y over change in x, which is equal to -6 over 1.8, which equals -3.333. D. 1. Complete the table for y equals gx, where gx is equal to 2 to the power of -x, for x from -3 to 3. So to complete the table, we just need to substitute the x values into the function for the missing spots on the table. So the first one is -3. So y equals g of -3, substitute x of -3, and that equals 8. And we can do the same for -2. So substitute the x in the function with -2 to get 2 to the power of 2, which equals 4. The other missing one is 2, so substitute x with 2, so that's 2 to the power of -2, which equals 1 over 4, or 0.25. 2. On the grid opposite, draw the graph of y equals gx. So what we have to do here is just plot the coordinates according to the table onto the graph, like that. And then we can join it with a smooth curve. So you need to like freehand this. Make sure that it's a curve and not straight lines dot to dot, because if you draw straight lines dot to dot, you're going to lose marks for that. So it should look like that. Then, part 3, use your graph to find the positive solution to the equation fx equals gx. So to solve fx equals gx, that's just the point of intersection between the two functions. So we're looking for the point of intersection between the two graphs that are on the diagram right now, between fx and gx. And we can see that they intersect at 2 points in the graph that we can see right now, over here and over here. The corresponding x values are -0.6 and around 1.9. So the solution could be -0.6 or 1.9, but it says use your graph to find the positive solution. So the positive solution means your solution needs to be positive. So the positive one is 1.9. Therefore, the answer for this one is x equals 1.9.